That straight road you're driving on, it's lying to you, and it's keeping you alive. Let's talk about why geometry saves lives. You think you're on a highway, you're actually on a carefully choreographed dance with Newton's laws. But what happens when you hit a turn? Physics doesn't care about your lane changes. When you corner, your body screams centrifugal force. Spoiler alert, that's a layman's myth. It's actually centripetal force dragging you inward. If the road stays flat, your tires have to generate every single Newton of lateral grip yourself. And rubber, it has a hard limit, so we tilt the asphalt. Engineers call it superelevation. We bank the road so gravity does the heavy lifting instead of your suspension. A 1-degree tilt shifts the force vector straight into your seatbelt. Suddenly, taking 100 kilometers per hour feels like cruising on a treadmill. But wait, what happens when you drive on a perfectly straight stretch for 10 miles? Your brain gets bored. Literally. Monotony drops your reaction time by 40%. The highway department hates straight lines because they cause microsleeps, so they hide the straightness inside gentle, rolling curves. Human processing latency is about 0.3 seconds. Multiply that by highway speeds, and you're blind for a football field. Engineers solve this with sight distance. They calculate exactly how far ahead you need to see before you can stop. If the curve hides the road, you don't build it. You regrade the terrain. Your dashcam doesn't lie, but your perception does. That stretch of concrete you swear is straight. It's actually a 1.5-degree arc over 2 miles. You're not driving on a ruler. You're driving on a carefully plotted Bezier curve disguised as a straight line. Now, the internet loves to scream about capacity. Just build more lanes. They yell, weak design choice. More lanes don't fix geometry. They just give you more room to miss the curve. We're talking induced demand, bottleneck migration, and friction coefficients that don't scale with asphalt width. Engineering isn't a parking lot. Roads expand. Asphalt breathes. In 1958, they learned the hard way that thermal stress cracks concrete like a dropped phone, so they introduce expansion joints and flexible subgrades. The curve naturally absorbs lateral thermal expansion. Straight lines, they buckle, they warp, they throw your alignment into chaos. Rain doesn't care about your speed. Water pools on flat roads. Hydroplaning happens at 30 miles per hour, so we crown the shoulders. We tilt the pavement inward to shed water like a duck's back. The curve itself acts as a giant gutter. Gravity and friction team up to keep your tires on the pavement. Here's the hidden math. The easement curve, you don't just snap from straight to banked. That's how you roll the car. Engineers use a clothoid spiral. Radius changes linearly. Centripetal acceleration ramps up smoothly. Your steering wheel turns at a constant rate. It's calculus you feel, not read. LiDAR doesn't rewrite Newton. Autonomous sensors map the world in millimeters, but the road still bows to the same physics. We're in 2005, and the geometry hasn't changed since the interstate era. Because when you're moving at highway speeds, math is the only thing standing between you and a guardrail. So next time you feel that gentle bend, don't fight the wheel. Thank the civil engineer. And if you're still begging for straight lines, that's not a preference. It's a skill issue. Drop your hottest take on road design in the comments. I'll be here, aggressively defending superelevation.